always transverse, and in empty space, they always travel at the speed of light. But although they always have the same speed, they can have vastly different frequencies and wavelengths. And in doing so, these waves go so far as to create the entire electromagnetic spectrum. As a matter of fact, only when electromagnetic waves have a wavelength in the narrow range from 4 to 700 nanometers are the waves visible light. That is the spectrum from red to violet. Even shorter wavelengths, called ultraviolet light, are radiated by the sun. Though these invisible rays are dangerous to living things, they're absorbed and rendered harmless by the ozone in the Earth's atmosphere. Shorter still are X-rays, with wavelengths the size of atoms. And finally, gamma rays, with the shortest wavelengths of all. Gamma rays, with wavelengths as tiny as the atomic nucleus itself, are created by nuclear reactions. Longer wavelengths, extending to visible light and beyond, can be created or absorbed when atoms change from one energy state to another. Beyond visible light, there's infrared. With wavelength longer than red light, infrared radiation can be detected only by the heat it deposits. The universe is suffused with long wavelength radiation, seen as the cooled remnants of the Big Bang that started it all. That includes not only infrared radiation, but also microwaves. Microwaves are the first part of the spectrum, whose frequency is low enough to be generated by human-made, alternating current electronic circuits. The universe is likewise full of radio waves. Centimeters, meters, or even kilometers in length, radio waves complete the electromagnetic spectrum. Of course, the great Michael Faraday didn't live to see the electromagnetic spectrum. Nevertheless, it began to take shape when, envisioning electric charges surrounded by lines of force,